Hey there, everyone. This is me, Mohammed Mamik, and welcome back to the second class of your data representation for grade 11 computer sciences. I hope that you have gone through the last lecture, and as per the last lecture, what we have discussed in the last of the classes was regarding data representation. I discussed with you that what is data representation and what is decimal prefixes, what is binary prefixes. I provided you the exercises for that and different materials. So I hope that till here the areas that we have discussed in the last class are clear to you, right? Like decimal prefixes, binary prefixes are clear to you, binary, denary, and hexadecimal, where all of these conversions are used, how they are used, why they are used, what is the purpose of each number system, what is their base, where they are used. This is completely clear to you. Just in case if you have any queries, please don't hesitate to ask. Feel free to ask. I'm here to help. I'm here to support. I hope that the conversions are clear to you, which is binary to denary, denary to binary, binary to hexadecimal, hexadecimal to binary, denary to hexadecimal, hexadecimal to denary. And just in case if there is any conversion where you feel like that are not getting it, so please type me a message or send me an email. I'll solve it right for you. Now, moving on to the today's class, we are going to move further with the next learning objective that we have in the today's class. So, okay, so just after this, what we are going to discuss in today's class is we have discussed this. We have discussed this. This is done. We have also discussed this as well. We have discussed this as well. We have discussed this as well. We have discussed this as well. In today's class, I'm going to discuss with you guys regarding one's complement, regarding two's complement for binary representation. I'm going to discuss with you regarding these one's complement, two's complement, BCD numbers, their practical application. So this is what we are going to discuss. So let's go ahead right here. Okay, so one's complement and two's complement. So even before starting this, I just want to give you the concept of that why there is a need of one's complement, so two's complement. So first of all, my class should be clear that we have integers, right? What is the reason? Why do we have integers? Right, like integers are basically like to be known as whole numbers. So if I'm referring to in terms of integers, that means that integers are of two types. It could either be a positive integers or it could either be a negative integers. So perhaps what really happens is that, for example, if you have a positive integer, like for example, if you have a number like for example 45, if you have a number like 60, so what you usually do is that you can consider this number as a denary number and you can convert that back into your positive one, right? But similarly, if you are given with some negative integer values, for example, I gave you minus 45, for example, I gave you minus 60. So how are you going to convert that? I'm sure that you have completed the conversion of binary to denary, denary to binary, but you need to think of that all of those were positive, right? But right now we will be working with the negative conversions as well. So for working with these negative conversions, the method I have right here is going to be two methods, right? One method that I use in converting them is going to be one's complement, and the other method that I use in this conversion is basically two's complement. So this is the basically the two of the areas that I work with that. So this is the reason that I have ones complement and I have twos complement. So now let's get into the concept of that. That first of all, what does it really means when I discuss with you ones complement? So basically, I have ones complement. When what really happens in ones complement is that you simply flip all the bits together, and by flipping means that, for example, if you have 1, it becomes 0. If you have 0, it becomes 1. So for example, if you have a number like, for example, 1 1 1 1 0 0 0 0. So if I am supposed to flip this, so what is going to be the answer? Now you can see that this 1 is going to be turned as 0. This 1 is going to be turned as 0. This one is going to be turned as 0. This one is going to be turned as 0, and the rest of them are going to be turned as 1 1 1 1. So this is to be known as ones complement. Ones complement is when you flip all of the bits together. So your 1 becomes 0 and your 0 becomes 1. So this happens in a ones complement. Now, if I discuss with you the second category right here I have is of twos complement. And the method for working with a two's complement is that you are given a series of number. What is the series of the number? The series of the number right here is like, for example, you have 1, you have 2, you have 4, you have 8, you have 16, you have 32, you have 64, and you have minus 128. So this is basically a number series for two's complement. And what two's complement helps you with is it is basically used to convert you helps you convert a negative term into a binary. So for example, if you have a question into your exam that using two's complement, calculate the binary equivalent of minus 127. So that means that you have the integer value minus 127 and you need to calculate the binary equivalent of that. So even if it was a positive, you can simply convert a binary into binary. But when it is a negative, now what you are supposed to do is that you are going to create this series: 1, 2, 4, 8, 16, 32, 64, minus 128. And you see that in this series, one special thing I have right here is that the last number right here is minus 128. You know what opportunity this minus 128 is giving me? This minus 128 is giving me the opportunity or the option to convert in negative numbers, right? That means that when you have a negative term, so this number can be used for calculating the binary equivalent. So for example, right now I have a question and this question says that I need to convert a negative of minus 127. So that means that I need only those values from this side which makes a total of minus 127. So for example, if I'm going to put a 1 here, so this is going to be minus 128 added. Now, if I add 64 here, is it going to give me minus 127? No. So this is going to be considered as 0. If I write 1 here, so minus 128 plus 32, is that going to give me minus 127? No. The answer is going to be different. So minus 128 plus 16, is it going to give me the answer? No. Minus 128 plus 8, is it going to give me the same answer? No. Minus 128 plus 4, is it going to give me the answer? No. Minus 128 plus 2, is it going to give me the answer? No. But minus 128 plus 1, you can consider minus and plus as minus. So if I minus 128 plus 1, I'm going to get this answer minus 127. And similarly, right, if I copy this answer right here, which is 1, 0, 0, 0, 0, 0, 0, 1, this is basically going to be considered as your binary representation of minus 127. So I hope that this minus 127 answer is clear to you and you don't have any queries. Just for giving you another example of 2's complement, let's say that if I have a number minus 127 and I need to calculate the binary equivalent of that. So what I'm going to do is that I am going to follow the same series. It's going to be like for example 1, 2, 4, 8, 16, 32, 64 and minus 128. So now the answer that I need right here is minus 47. So basically what I need to do is that I need to make minus 47 here. So if I take minus 128, yes, I need to take it. This is must. So if I do not take it, I will not be having the answer in my negative terms. So if I take minus 128 and if I add a positive of 64, then the answer is 64. So the answer is greater than that. I'm going to go along with this minus 128 plus 64. But if I add minus 128 plus 64 plus 32. So the answer is going to be 32. So let me repeat it again for you. I have taken minus 128 and I have taken a positive of 64. So minus and plus results in 64. So I can take it, right? 64. But now if I am deducting 32 from 64, so if I'm deducting 60, 32 from 64, it results in again 32. That means that the answer is going to lower side and I need a 47 that is higher. So I'm going to put a 0 here. So should I take 64 minus 16? So if I check this 64 minus 16, this results in 48. Okay, this is correct. Now I have 48 here. What I need to achieve is 47. That means that if I remove 1 from that, I will get the answer. So no 8, no 4, no 2, only 1. So this is going to me generate my answer for minus 1, minus 47. And let me check this again. Minus 128 plus 64 plus 1. Oh, oh, just a moment. I made a mistake here. It's basically minus 128 plus 64 plus 16 plus 1. This results in minus 47. Now it's correct. So minus 128 plus 64 plus 16 is 48 and plus 1 is 47. So this is the correct answer. So this is it for your two's complement. You use two's complement for converting negative terminologies into the binary one. I hope it's clear to you. Now we need to discuss the third terminology right here. And the third terminology right here in today's class is that going to be what are these BCD numbers, that is binary coded decimals. And we need to discuss their practical applications where BCD codes and hexadecimals are used. So I'm going to carry the lecture along with that. I hope one's complement and two's complement is clear to all of you. Now, what is basically a BCD number? The name itself says binary coded decimals. I mean to say that what I understand by this term is basically like if I have a decimal number. I believe that decimal numbers are those numbers that are understandable in my everyday life. And if they are understandable in my everyday life, and they are being shown to me, so even before they are being shown to me, they are being responded into some sort of binary codes, right? Like, I mean to say that, for example, if I have a number such as 8 and 8, now what is going to be the binary coded decimal, right? Like, for example, this number itself is a denary number, right? This is denary, and this one, this is also denary. But what is going to be the binary code of that? So binary code is going to become right here. That is going to represent that, for example, 1248. 1248. So this is going to be 1 0 0 0 1 0 0 0. So this is basically the binary representation of 8. I just converted this 8 into binary. So I hope that you are getting the point. Binary coded decimals. When I check for the binary value of that coded decimal, it is to be understandable as a binary coded decimal. If you do not understand, listen it again. For example, if I have a term such as 1 and 1, this is denary for me. But if I want to understand that what is the binary code of that, so I'm going to convert this denary into binary like this. 1248, 1248, perhaps this is going to be 0 0 0 1 0 0 0 1. So this is basically the binary coded of this decimal. So I hope I am clear to you. So let me make it more even clear for you. So what are binary coded decimals? These are basically storage of a binary value representing one denary digit in a nibble. Nibble basically stands for half a byte. That is known as is equals to 4 bits, you can say. So binary coded decimal is a storage of binary value representing one denary digit in a nibble in a 4 bits, representing one denary digit into a nibble into a 4 bits. You can see that this is 4 bits right here. This is 4 bits right here. So digits are coded as the binary value from 0000 to 1001. So codes are from 1010 to 1111 that do not have any meaning. And if I have a packed BCD means that when two BCD nibbles are stored in 1 byte. And some of the applications of the BCD number is like, I have digital time display, I have calculator, I have currency values. So they can be considered as a BCD number. So I hope that the concept of BCD numbers is clear to you. For making it a bit more clear to you, I have attached this concept document with this recording. So you can basically see that what is a BCD, a binary coded decimal is a form of binary representation where each denary digit is converted individually into a binary rather than I'm converting the whole of that. So for example, if you have a number 42, so this number, if I convert the full of it into an 8-bit binary, it is going to be this, right, like the conversion to understand. But if it's a BCD number, so what I'm going to do is that I'm going to break it into two areas. The first is going to be 4, the second is going to be 2, and then just by aligning it with the table of 1248 and 1248, I'm going to calculate that exact value, right? Like, if you can see it now, I hope it's clear that you can see that I have basically calculated their placeholder values, that if it is 4 and if it has any other value than that as well. So this is it for 4 and 2. And similarly, if I would convert the whole of that, it is going to be into a different format, but this is not basically what we are referring to right here. Uh, Let me just make it a bit clear for all of you. Okay, so therefore 42 in BCT would be this answer, because I'm going to take the individual values of 4 and 2. Then other than that, why do we use the binary coded decimals? binary coded by decimals has three main advantages. What are those advantages? It is easier for humans to read large binary numbers than if the number is in pure binary. It is easily to read. It is simpler to create hardware that only counts in decimal and use basics calculation, right? Like digital clocks, calculators are examples of the BCD number. If you are going to view it on the screen, they are represented to you with the help of BCD, and BCD basically removes the problem of floating point rounding error, which is useful for handling transactions. It basically means that whenever you are working into banking, you are working into transactions. So there you basically have this problem that rounding off error, because sometimes the value goes too long. So when the values go too long and you have to write it accurately, here the problem arises. So this problem can be solved by using a BCD number, because no matter how much the longer the the problem is, it can be understandable right into binary for the computer system. So this is why BCDs are used. Just for giving you a demo of that, this is basically a demo link that I have shared right here. So let me give you an example of the how do this BCD actually works. So, uh, as you can see right here, this is the demo of that. This is basically a clock, and you might be wondering that how it is being used in a clock. So you can see that these are the hours, these are the minutes, these are the seconds. So for me, that the denary number is the hours, minutes, or seconds, but behind that you can see that this is basically the binary coded calculation that is being going through around this, right? Like for example, 000000, so things like this. So this is a binary coded decimal. Like for example, if I if I just take you right here, you can see that if I want to convert a zero into a BCD number, so 0 1 2 4 8. How, what is going to be the answer? The answer is going to be 0000. Hence this. If I want to convert one into a BCD number, so one, it's going to be like 1 2 4 8. So the answer is going to be 0001. If I'm going to convert 2 into a BCD number, it is going to be like 1248. It's going to be 0010. This is the answer, and so on. You can see that I have 3, 4, 5, 6, 7, 8, 9. A BCD number only covers the value with 4 bits, and if this is 4 bits, this is going to be considered as one nibble. That means that half a byte. So there are some questions of that, and I will be sending it to you as an activity. So that's it for today. I think that we have covered so far what is BCD, what are the practical applications of BCD. I discussed with you the practical applications as stopwatch, calculator, handheld devices, financial transactions. Other than what are the practical applications of hexadecimals, we have covered it into the last of the lecture, and we discussed that hexadecimals are used in color codes, in error codes, in HTML codes. So these are basically the applications of that. So I hope it's clear to you. For just in case if you have any question, please feel free to ask. Don't hesitate at all. I'm here to help along with this video lecture. I'm providing you with some resources as well, some activity as well, so you can complete it and you can carry on with your work. So best of luck. We will meet in our next class till then, inshallah. So thank you very much.